Hello everybody, my name is Craig Bennett, and today I'm going to be getting into a networking video, and we're going to get into switches. What is a switch specifically? What is some of the things it does? What differs it from a hub? Why you should avoid hubs? And a few extra things you may need to know for network engineering. So as far as things goes, what a switch looks like is there's two different types. And the first is a normal switch, and this is something made mostly for homes or small offices or something like that. It's something more of a lines of plug and play. Basically, you plug it in, it works, and it's good to go. But then you have something like this where it's a managed switch. A managed switch will have a console cable, and basically what that means is you can manage it. There's probably other ways for you to manage some switches, but my personal experience with Cisco equipment is a managed switch will have a console port, and there's entire things into that. Now, as far as that goes, a normal switch like this, if you go on Amazon, eBay, or something like that, it's normally, I think I got one like this. It's a different brand and everything, but I think I bought it for $20 or something like that. No, in fact, it was less than that, but I've seen them down to $10, up to $30, something around this. The more ports, the more money it's going to be. But with that in mind is when we get into managed switches, something around to this, it goes up. You can go into from these normal switches being $10-20, maybe a little bit more. These can get in $100 or more. Now, note this: a average person does not need a managed switch. A managed switch is great for enterprise use and for medium to large office use. But as far as small office use, like a small doctor's office to home use, I would say go with a normal switch, a plug and play type of thing. One thing I want to note is, and this is something that you're not going to get from a lot of people who haven't played around with these for a while, is normal switches like this. Sometimes they can act up. I've had problems with switches like this, having problems with voice over IP, VoIP, something that's very common, especially in today's enterprise world and today's home world. So the way I fix that is just unplug it and plug it back in as far as the switch goes itself. There's not much you can do as far as a unmanaged switch. With a managed switch, you can easily fix that, and you have to go through and figure out what's causing the problem in the first place. But with a unmanaged switch, a normal switch, there's just really nothing you can do besides maybe switching out the actual entire switch itself, or just unplug and plug it back in, and that's best that you can do at the time. So with that in mind, what I have here is a quick diagram of some switches. So you can actually have your switches hooked up from switch by switch to switch. You can have a multi-layer like this, but the thing is to keep in mind is, in order to go out to the internet and stuff like that, you need to take a look at routers and stuff of this nature. Switches is great for something like if I have a entire building full of IP cameras, I can actually hook them up, hardwire them up into switches, and that way it all goes to the proper place. Same thing with computers and stuff like that. I can hardwire stuff in. I can get quite a bit of extra speed by going through hardwire as far as Ethernet ports versus wireless, stuff of this nature. Then there's security that's added onto it by using switches versus wireless or some other things. Obviously, some cases you would just use wireless because it's easier or something else. But for enterprise level or small home or office, switches is worthwhile to take a look at. I wouldn't use if you're able to pick up multiple unmanaged switches. for very cheap amounts and whatever, and it doesn't have that many ports, but you need quite a few of them. Something like this is fine, but normally I would not do something like that. Normally I would just put it all on one switch. But again, if the price is really going to dictate on what you're going to be able to do right there. For match or unmatched switches, what happens here? The difference between a hub and a switch is how communication happens. So let's say, for example, you're labeling on your ports, your computers or whatever, and you'll find this in schools, a big time in schools, and also offices and stuff like that, but mostly in schools, is you'll have labeling. One thing that I've seen in enterprise level in schools is the Ethernet cable is, you'll have a technician or something that will literally plug in the Ethernet cable here, put tape on one end if it's like a very, very long Ethernet cable, or if it's going through multiple things. What would happen is they'll put tape on one end and write a number, something like you see here, and then tape on the other end, and that way you know what's what. Okay, you're seeing 10 on that end, and you're seeing 10 on that end. Instead of falling to rat's nest, you can actually go ahead and figure out which Ethernet cable is to what. That's worthwhile to note. So if you're going through technician type stuff, doing cable management and stuff like that, that's a good note to note. But depending on how your configuration is and how your labeling is depending on all that stuff. But let's say that each one of these is an independent device for a computer. What happens is with a hub and a switch, what happens with a hub specifically is when, let's say, for example, device 10 or computer 10 wants to talk to computer 17, it has to go through switch 1, 2, and 3 to talk to it. So what would happen with a hub is all the devices will be broadcast out. Say 10 wants to say hi to 17 for whatever reason. Well, what happens is each one of these gets that hi. This causes security problems into itself, where I don't want 11 to know what 10 is saying to 17, because 11 might be tapped into some hacker or something like that. There might be some security flaw right there that just happens. So maybe 10 is sending classified information to 17, and 11 is the marketing department. Like maybe we're in a government complex or a some type of thing like that. 10 and 17 is very top secret. 11 is some marketing or PR or something around that nature, where the security is suspected to be horrible, or at least is expected to be extremely vulnerable. So what would end up happening is without extra security on top of it, what would end up happening is 11 plus all the other ones will know what 10 is saying to 17. Here's the thing. When a computer does, for a switch, a similar thing does happen. When a computer connects to a switch, so for example, if 10 connected to switch 1, when it goes and deals with the DHCP stuff, it sends out a broadcast of the MAC address. That's it. It doesn't send out, a hi to whatever. Past that point, it's secure, or it's theoretically secure. But what happens here is, say you plug in 10, like device 10 being a computer or printer or whatever it may be, into switch 1. What happens here is switch 1 now knows the MAC address to device 10, but it broadcasts out that broadcast, when this connects, it sends out a broadcast. It broadcasts it out to all the ports that have something connected to it. And what happens here is, all right, so one knows the MAC address because switches don't. Managed switches can know the IP addresses of the devices. However, more than not, it's just going to know the MAC address. So what's going to end up happening is, since it broadcasts the MAC address out across the entire network, there's ways to stop that, by the way. So just note that there's exceptions to that rule. What happens here is switch 1 broadcasts what 10 wanted to broadcast out to all its ports, so 11, 12, whatever. Same thing with 2, 3, whatever. So 1 knows which port it's going to. The problem is 2 and 3, the device 10, say for example, if device 10 is in port 10, what happens here is switch 2 and 3 doesn't know which exact port it's connected to. However, it knows the direction of the port, the device. So, for example, 2 knows that by going through this port, you just name a port off your head that's connected to this switch. The device 10 is connected to it somewhere down the line. It doesn't know if it's this switch or some extra switches down the line. Whereas device 3, all it knows for device 10 being connected to it is it's through this port that's connected to switch 2. It doesn't know about switch 1. It doesn't care about switch 1. All it knows is the devices 10, 11, 12, and 13 goes through this little cable going to switch 2, which is fairly important because switch 3, it simply does not know or doesn't need to know exactly which ports it goes to and specifically which exact switch it goes to. It just needs to know, in order for these devices 14, 15, 16, and 17 to talk to 10, 11, 12, and 13, it needs to go through this port which connects it to switch 2, and then switch 2 needs to then know these particular devices. Say if like 14 wants to connect to 10, then 2 needs to know 10 is on that, and it goes from there. That's all it needs to know is which way to send the information. It doesn't need to know the exact address, doesn't need to know exact location, doesn't need to know exact switch or anything like that. It just needs to know where to send the information. That's it. So that's fairly important to itself. Now, as far as broadcasting goes, for a switch, that's it. For a hub, that's all it does is broadcast. For a hub, for device 10 to talk to device 17, is every single device. Like, say for example, if 10 wants to say hi to 17, maybe send a message or request something, every single device is told this. Every single device can actually do what's called a capture and snooping. You can use something called Wireshark, can enable a few other things to capture stuff. There's massive security problems with that. Let's say that that's not a concern. Maybe it's a completely secure network and that's just not going to be the problem at all. There's still other problems because 10 is trying to connect to 17. Let's say at the same time, the exact same time, 14 is trying to connect to, let's say, 13. Well, what happens here is as it's going from 10 to, from switch 1, switch 2, switch 3, somewhere in the middle, I can't tell you exactly where because it depends on speeds, depends on a few other things, but somewhere in the middle, there's going to be something called a collision, a data collision. And what a data collision is simply this. Think of it as two cars heading towards each other on a head-on collision. Neither car, both cars, same weight, same everything else, so that variable is there. But neither car with that type of variability into it is going to pass each other. You're not going to have one car that just keeps going. It's not like a semi truck and a smart car where it's almost like in a tin can where it just keeps going. No, what happens is both cars head on collision, they stop. And the car A trying to get to somewhere, car B trying to get somewhere, that stops. That's the thing that you got to keep in mind with data collisions. 10 trying to talk to 17, 14 trying to talk to 13. Somewhere in the middle, there's going to be a data collision. This is going to result in loss of data. This is a problem with hubs. See, if you want to buy a hub, that's fine. If you want to buy a hub, that's perfectly fine. You can pick them up for little or nothing, $2-3, easy. It's sometimes a little bit more, but $2-3. I would not use a hub in anything that uses more than 3 devices. In fact, I really wouldn't use it anything more than 2 devices, but sometimes you gotta sacrifice a little. So 3 devices. Once you go into that 4th device, you need to go for a switch. There's just hands down. Once you see what happens there is if you only have like 2 devices on the entire system as far as the hub goes, well, the fact is there's not much room for a collision there. There's not much room for problems. You don't really have much room for a security problem. You don't have much room for any other real major problem unless someone physically has access to the system, which you have a whole set of new problems right there. Well, the thing is with a data collisions and broadcasting out, that's eliminated when you go with a switch. Basically what happens here is 10 wants to talk to 17, and 14 wants to talk to 13. What happens here is it queues up the information. So somewhere on the line, so let's say for example 2 is the middle point. So just arbitrarily, so saying 2 is the middle point. Maybe they send the exact same time, same equipment, same all that stuff. So 2 is the middle point. Well, what happens here is it will figure out which is in force and just go with that. So the thing to also note is since these switches, they will actually need to know not so much as far as which switch is 10 connected to, unless if it's to 1, obviously. They would need to know the devices that's connected to it to help it figure out where something is. Because what happens here is, say for example, if 14 it wants to talk to 10, and for some reason 3 doesn't know where 10 is, and this can happen easily with cheaper switches, is 3, it will actually send out a broadcast to all the ports asking where is 10. And basically 2, if it says, oh, I know 10 is here, even though it doesn't, didn't ask 1, it already knew 10 goes through that one port. It will send out a thing out to 3, say, hey, it's on my end. Or if it doesn't know, then 2 will send that out to all the ports except for the one that received the broadcast message. And what would end up happening is keep going until it either times out or finds the switch that actually has the proper information. That's fairly important to itself, because what happens is the more expensive the switch is, the bigger the table is that can hold the MAC addresses. So if you got a large system, like for this, believe it or not, it will be considered as medium to large. Normally with homes, you only have 1 switch, maybe 2 switches, depending on what you're doing. Obviously, you can have a little bit more with the ports and whatever. Maybe you could put switches on one side of the house, the other side of the house, and connect them through that method. Fine. But more than not, what you're going to find is 3 more is medium to large enterprise level, especially with a large amount of ports on them. But with that being said, what happens here is the cheaper it is, the less it's going to be able to hold. So you're only having it broadcast more, and that's going to slow down the entire network, and that's going to cause problems. So let's say, for example, that you have one really, really good switch on your enterprise network and maybe 10 horrible switches, low-end switches that it simply does not have enough memory for the amount of devices you have. Well, it's going to be very, very possible that will slow down the entire network to a point. Trying to ask for, hey, this device, 10, through trying to figure out where 10 is. Hey, where is it? For a configuration like this, it's not going to slow down that much, but when you get a lot deeper, especially higher end enterprise level, where you're going to have more devices, more switches, more stuff, that's where having better switches really come in play. So that's something to keep in mind. Now, with that one in mind, something that may help you save money, you can have like something like this where you have 3 main switches. Maybe it's certain parts of a building, or maybe it's a school or something like that. And then you have each one of the ports is an air switch. It's a crap switch, whatever. Can hardly hold anything. But what happens here is each one of the main switches, they can hold all the devices or just about all the devices. So what happens here, let's say, for example, 7, it doesn't recognize 11 anymore for some reason. Maybe the table filled up and it's just, doesn't remember anymore. It'll ask 2 with the broadcast. 2 says, oh, I know what that is. And it'll just tell 7 and goes from there. The fact is you can get away with things like that, fine. But if all the switches or majority of the switches are low end, you're probably going to slow down your entire network. So that's something to note when you're building out a network. So a question that comes up, and something that you will have to learn in school or for CCNP or something like that, is what happens if you have a configuration like this, where 1's connected to 2 is connected to 3, but also 1 is also connected to 3. Well, what happens in back in the day is it'll be a bad thing. Basically, what happens here is some people call it a ring death or something like that, but it's you'll see the ports flicker faster and faster and faster until it just gives out. Basically, it'll clog up the system. What happens now with modern day systems, let's say, for example, you got a technician, they accidentally connected 1 and 3, didn't realize 2 was connected. Well, what happens is it will auto detect that 1 and 3 is being connected, even though it's already being connected to 2. So it will kill off the ports. Basically, it will just disable the ports automatically. It's called a spanning tree. That's something to note. And you can, with a managed switch, you can modify the spanning tree fairly easily. I think I got videos on this already in the past on specifically spanning tree, but with that one in mind, it is important to note modern day switches should auto detect if you end up having a connection, a redundancy in the connection, and it will disable the ports that's needed. So, for example, it detects, it's already going through 2 and 3 from 1, so it will just disable this port, and 3 was disable that port, and that way, you have to enable in whatever, or when you're on a unmanaged switch, a dumb switch, what happens is once you disconnect it and reconnect it, it will treat it as a brand new object and track it and go from there. So that's something to note into itself, is that switches have the ability to do this with modern day equipment. Now, as far as a question that might come up from someone who's just walking into this blindly, is someone might ask, well, what's going to keep device 10 and say device 16, hypothetically, from having the same MAC address? The truth is what's taught in schools and taught around is each device in the world has a very individual MAC address. And that means that no two devices in the world should have the same MAC address. The thing is, I don't believe that's the case, but statistically speaking, that's highly unlikely. Note that there is an ability on Windows and fewer things to actually have it. Any time that you connect to a new network or the same network, it will spoof the actual MAC address, and which is a physical address, and that way no one can like say for example, if you're going from, say, switch 1 is, I don't know, marketing department, and switch 3 is IT department, and switch 2 is executives, and you're going between them and maybe taking a laptop between them, no one can actually, track you through that method. There might be some legitimate and obviously illegitimate reasons to do this, but you can actually spoof the actual MAC address in itself, which isn't a problem. Just make sure that you don't run into some problems where if a system detects that it is spoof, if the security is up on it and properly set, it can actually cut you out. There is ways in systems. Say, for example, the MAC address for device 10, the system's looking for it in anything besides device. There's ways for managed switch, and this is something that they teach you for CCNA and CCNPs. For, let's say, the device 10 is on port 1. There's ways I can make it where port 1, if device 10 is not plugged into it, if it detects some other MAC address into port 1, it will not allow it to communicate or even acknowledge into a network. Switch 1 will basically say, no, you're not allowed to talk to us in this network. There is ways to do that. It's for security reasons. So say, for example, if you got a hacker that somehow got physical access to the system, and it's a managed switch, a dumb switch, there's not much you can do, but a managed switch, you can say, okay, with 11 maybe being in some supply closet or something like that, and say a hacker plugs their device into it, and it's very critical that you don't have a hacker into the system. Maybe it's a government system or something like that. You can actually say that if it isn't the MAC address for device 11, then don't allow them communication at all into the network. There's ways to block things like that. So it's very important to note that if you're spoofing your MAC address, you need to note that, especially when you're doing enterprise level stuff. It's great to test your systems so you can actually go ahead and spoof it to see if the security is right in case you're doing training. But as things are, it's fairly important to note the security abilities for the switches and routers and stuff of this nature. Now, as far as one thing people might remember if you watched my past videos in networking and hacking is this highly relates to some hacking attacks, man-in-the-middle attacks like ARP poisoning. I have a video from a while back on ARP poisoning. It's still one of my favorite hacking attacks even today. And instead of rehashing what I said there and showing the stuff in detail there, I'm just going to leave a link down below in the description, so feel free to check that out and check out the other links there. Now, one thing that you might notice is, as far as switches goes, there's quite a few different types. And what do you need to know when you're buying a switch? First things first is you need to know how many ports you need. And this is a major thing, is the example I gave here. This is likely to happen, but it's not best practice, especially with what I was talking about earlier with like 8, 9, 10, whatever is a switch into itself. That is definitely not best practice, but it can happen in the real world. You're limited to your resources. One of them is money, and that might be the cheapest and best solution that you can come up with, maybe in a major situation. But as far as that goes, you need to buy as many ports as needed. So for example, if you only need 8 ports and that's it for the foreseeable future, then great, just buy the 8 port switch. If you need 16, 24 ports, whatever it may be, then you need to go for something like that. There's other things you got to keep in mind with that, but the reason why you don't want to do the having a daisy chain type of thing, let's say for example that 10 is its own switch. Well, what happens here is, let's say 3, it's communicating out. Each switch, modern day switch, they should have a speed of a gigabytes per port and per area. So what happens here is, by daisy chain on that, you automatically slow down the entire network, but specifically the communication between that, and that causes problems into itself. Good switches, cheap switches, you can easily put out the same speed across the network. So for example, like a 3, it's a good switch. It will put out like a same speed across each one of the ports if possible. But the thing to note is, even with that, going from 3 to and back from 1 to 3, is that will cause a bottleneck, and that will slow down things. Especially, this is where it gets a bit critical. So let's say that you have 14, something on 14 that wants to talk to 10. What happens here is 14, and also you want something 15 talk to something on 10. Maybe they're both switches, it doesn't matter. Well, 14 and 15, it wants to talk to 10. Well, it only has a limited amount of speed to go through. So if 14 is going through that's the port, then 15 has to wait, and that's slowed down. And that, depending on the size of your network, that can slow down the entire network, where you can either have timeouts or something like that. That's usually a bit more of a thing that you don't see, because usually you tend to have other problems that happens before we get to that level. But a thing to note is the communication between, for the Ethernet, for this port to this port, only one thing can go through at a time. And because you chose to, instead of maybe 1, 2, 3, 4, maybe you got a 4-port switch, which is not a lot right there, and another 4-port switch, instead of going for an 8-port switch and plus whatever that is. Well, what you can do, what you just done, is you just slow down the network, because any communication between those 2 ports into itself, only one thing has to go through. So if it's sending something from 2 to 3 or 3 to 2, then whatever communication that's left over will have to wait, and that bottlenecks the entire network. That slows down the entire network. Hope that's easy to understand. Feel free to ask if you don't understand that, but it's fairly important to note that in a home atmosphere, I don't imagine this would be much of a problem, but once you get into the enterprise level, it can become a serious problem. You basically want to make sure that whatever switch you get, you can hook up all the devices to that one switch, or to least amount of switches as possible. You don't want to flood your entire house or store or airport or whatever it may be with 4 switch ports. You don't want that. You're going to have problems with one plugins, but the other, and this is fairly important, is bottlenecks. Anything communicating from one side of the airport to the other side of the airport, it's going to have a slowdown problem, and that creates other problems into itself. So it's fairly important to note, use as least amount of switches as possible. Just mention speed real quick. Normally with modern day switches, you don't have to worry about it, but try to go for a Ethernet speed. Basically, try to go for the best speed as possible. It's actually very difficult to find a switch that has slow speed nowadays. Maybe if you buy something off eBay, but even at that, it's very difficult to find something. But then again, you can find old hubs on eBay, so just watch out for that. So know the speed and whatever, because that in itself can cause problems. And thing to keep in mind, brand name switches, they tend to be able to put out for each one of these ports full speed, whatever it may be. Some off-brand, I'm not going to guarantee that all of them can do that. Can put out full speed on all ports at the same time. So that's something to note. Something like Cisco, Juniper, or something like that, they should be able to put out something like, say for example, if it's a gigabit speed going through a given port, theoretically, if all ports are communicating, it should be gigabits through each one of the ports. But off-brand, that might not be the case. So if inferior products, inferior hardware and software and whatever. Another thing to note is something called Power on Ethernet, or PoE. Power on Ethernet is fairly important, because what happens is if you have a PoE, and to know if you got a PoE switch, you just need to look at a manual and take a look at it. It will specifically say it. Whenever you're buying switch, just look up PoE switches. But basically, a PoE switch is a little bit more money. But say, for example, if you have a IP camera, most IP cameras have PoE ability. And what PoE is, power over Ethernet, is the IP camera, or in this case, let's say this PC, let's just say that's IP camera or an Internet of Things type of device. And instead of having to run a cable from an outlet or some power thing to the actual device itself, for example, in this case being an IP camera, not only the Ethernet cable can support the data going back and forth between the IP camera and the switch, but the actual the cable itself powers it because of the power over Ethernet. It's fairly important to note that, because you tend to have to pay a little bit extra, not too much. But when you go into some security systems and things of this nature, depending on the size of the place, how many cameras and stuff of this nature, you may want to cut down as much as possible when it comes to wireless and go for wired if possible. And in order to save space and stuff of this nature, because you're not going to have a outlet and everywhere there's going to be a camera or a need for a camera, you would just need to use a PoE, and that way you double up on cutting down the amount of devices that are over the wireless network. Plus, you don't have to find an outlet for it. As long as the Ethernet can reach it and it's over a PoE, then it's good enough. Note that you can actually buy PoE adapters. I personally have some PoE adapters, and what they are is you hook up one end to outlet and hook up the other end to Ethernet cable, hook that up to a camera, and then have the camera just go through Wi-Fi instead of the Ethernet. And that works into itself, so you can power up the camera through that. So note that there's that ability in itself, but you obviously have to have outlet at that point. But for switches, note if it has PoE or not. It's something very worthwhile, especially when you get into security systems and Internet of Things and stuff of this nature. Oh, and because I forgot to mention this, the thing with the ports, as I mentioned before, you want to make sure that you have enough ports for whatever you're doing. It might not seem obvious or something easily forgets. Like in here, you might say 1, 2, 3, 4, 5, 6, 7. And the thing to keep in mind is the router itself, or if you're going from switch to switch, that requires a port into itself. So, for example, if you need 8 ports, you might have to go a step further because of you need that one extra port for whatever it may be, unless if you're counting that like modem or router, whatever it may be. So with that in mind, that's something to keep in mind with that. Now, as far as another thing to keep in mind when you're buying a switch is the manage level. You want to make sure that it's a manageable, and when you're going through the store stuff, it will say manage or unmanage or smart switch. And there's different manage levels and different things that you can do on these switches. I'm used to Cisco level equipment. I'm not too much used to the lower end stuff. The dumb switches, I actually got one something that looks something like this, different brand and everything. But as far as the smart switches, which is between the fully managed enterprise level to the dumb switches, I'm not used to that, so I can't really tell you too much of as far as the advantage of that. But one thing I could tell you is some switches, if depending on the manage level, you can only set up things like policies and things of this nature. Whereas I'm used to what I play with, or what I used to play with Cisco equipment, it is like ISP type of level. It's higher in level, and there's a lot more you can do with it. It's a lot more than what you probably need in most cases. So just note that the manage level and the prices on it. Buying more than what you need is not a problem. Just make sure that the price is there. Just don't buy too little. Thing to note is you can set up things like VLANs and stuff like that. I might make an entire video on VLANs. If I hadn't already, I gotta check that. But VLANs is basically like a firewall into itself. But if you're going for a manage level, make sure it can do VLANs. That's just a raw thing. It's possible, as I said before, where, like, say for example 10, if you program it where for a managed level switch, if the MAC address is different from what it normally is for 10 or whatever you set for 10 should be, well, and someone else plugs something else in there, you can block that communication altogether. Well, let's say for example you're at your home stuff and someone's playing around, maybe a kid or something else, and for device 12 they plug something in. Switch 1 doesn't understand what that is. So what would end up happening is it will create a VLAN. Any communication 10, 11, 12, 10, 11, 13, whatever, has it. 12 won't be able to see. It's on a different type of thing. It's a different thing for security purposes. VLANs, just getting into it real quick, is for enterprise level. If you got, say, a marketing department, a sales department, a IT department, so on, so on, so on. Well, let's say that the marketing department gets hacked. A VLAN theoretically should keep the other departments from getting hacked, unless if they use some other method thing going through the network itself. Like if they use some type of virus that the marketing department got, then they've emailed the sales department, so on like that. That's one thing. But if they got access, say, to marketing departments, PR marketing is one of the most vulnerable departments in the business because they're always communicating with people outside, whereas IT and a few others, they should almost never communicate outside, very rarely, so they can be segregated from the any connection going outside. So if something gets hacked, It theoretically won't go to the other departments. That's one big area that's useful. I think I did a video in it. If I did, then I'll leave a link down below that. So check that out. It's in the description for any link. Lastly, you need to know the sound. This is something that's fairly important. If it's fan or fanless, so dump switches like this, like what I got, it's fanless. There is no sound that comes with it. There's nothing for it to make a sound. Once you get into switches with fans on it, the more ports it has, the more likely there's a fan on it somewhere in the back. What happens here is it can get very, very loud. Usually, I've never heard of any router, switch, server fan, anything like that go anything besides 100. It's very loud, and the reason for that, it just gets hot, and dealing with all the ports and whatever. If you got everything active, then you got problems right there where it needs to be able to cool itself off. So the thing to keep in mind is, let's say that you got an open office and whatever, and the switch is in the open office, or maybe in your living room or some other area. You don't want the thing to sound like a server farm where it's so loud, like a bunch of vacuums going on all around you all the time. So you want to make sure that you put it in some type of ventilated closet. Make sure it's ventilated because, heat. There's a reason why there's a fan on it. So put it in some type of ventilated closet or something of this nature, air conditioned closet or something this. And what that would do is that way you can block the sound from causing problems. But so the last little bit of information I'm give, because I'm pretty much said most of what I'm going to say, is and I figured that if you're here this long, then you really want something worthwhile. Is, let's say for example, these are different buildings. So building 1, 2, 3, got switch 1, 2, 3 in the buildings. If the building is very far away, you need to, I don't remember off the top of my head, but I actually have videos onto this in the past with EMI, electromagnetic interference, and a few other things that you got to keep in mind when you're running cables from one building to the next. Is there is some switches that you can hook up fiber optics or other things to it. And fiber optics, it's glass. You don't have the interference, and as there's a max distance with that. I might get an air video on that because there's a lot of math that goes into that to figuring out how far you can run something before you run into problems with the signal weakness. Even light has its own distance problems, which is fiber optics. So that's something to keep in mind. Obviously, and I want to mention this real quick, if you're ever dealing with fiber optics, don't actually look at the stuff. It's basically a laser. It'll burn out your retina. But what you need to keep in mind is if the distance is far enough, I think it's around 300 feet or more, you might want to take a look at fiber optics. Again, I'll get into another video on that to pull up all the information, so I'll make sure it's 100% right and everything else. A little bit of research goes behind that. But with that in mind, that's something to note is if you need a fiber optics ability for the switch. And that's something that's worthwhile if you're doing like a long daisy chain, because fiber optics tend to be around 10 gigabytes if I remember right, maybe a little bit more. And most devices, they won't even recognize that. They will be able to use up to that, but they won't even, most Ethernet ports and stuff like that, they won't even be able to send out that much information compared to a fiber optic. So you don't have a bandwidth problem, whereas like with here, daisy chain it, each one of these, that's going out. It has only a limited amount of data that can go through it, and if you're using all the data, which is probably going to end up happening because it's all the same stuff, what's going to end up happening is it has to wait for the communication get done from here to here and back and forth before it can communicate something new. Whereas fiber optics, you're probably not going to use up all that data. You're going to have reserve left over, so that means that you can actually go off and daisy chain it, and as long as you don't go too far with it, you won't have to worry too much about the bottleneck that I was talking about earlier. But anyways, it's been Craig Bennett. Leave a like, subscribe, share, and whatnot. I'll see you next video. Hope you have a great day.